I'm an artist, and I'm inspired by mathematics. Now, some people think of mathematics as algorithms and boring formulas that have very little to do with life or being alive. But with my art, I want to show that mathematics is all about life and beauty and patterns and connections, and that these can be some of the most inspiring things of all. I'm going to show you how one mathematical pattern led me to create art and music and poetry and literature and a lot of other cool stuff. And this story begins about 20 years ago when I was playing with a puzzle called the Towers of Hanoi. It usually looks like this. It's a stack of discs on some pins, and the idea is to take the stack and move it to one of two other locations just by moving one piece at a time, and you can never place a larger piece on top of a smaller piece. It's a fun puzzle. It's easy to make mistakes, and it's full of some really cool patterns. And when you get into the patterns, you can solve it very quickly and easily, like this. 1, 2, 1, 3, 1, 2, 1, 4. 1, 2, 1, 3, 1, 2, 1, 5. 1, 2, 1, 3, 1, 2, 1, 4, 1, 2, 1, 3, 1, 2, 1. Okay. Okay, here's the list of moves that I just did. And you can maybe see some structure here already. There's interesting groupings that repeat themselves on larger and larger scales. And one of the first things that I did with this was I represented these numbers as lengths that doubled from 1 to 2 to 3. And we can see some shapes already. Here's some triangles. It looks kind of like mountains. Maybe we could turn this into a landscape. Yeah, that could be cool. Let's see what other patterns we have in here. This looked familiar to me. This is the pattern on an English ruler that I grew up using. And here's the solution to that puzzle in the space of 2 inches. If we rotate this 90 degrees, then you might recognize this shape as a playoff tree. We rotate it again, and we get, well, like an actual tree. And if we even out those angles a little bit, we get something that's very organic looking. And in fact, this is a shape that we find all over nature. Another place we find this in nature is in a family tree. Right, we each come from 2 parents, and each of our parents come from 2 parents, and each of them from 2 parents. So in a sense, we are right in the middle of one of these trees. That inspired me to make this picture where instead of using line segments, now I used actual people. And this shows how we're all part of these trees that connect backwards in time through countless generations. If we want to get a little bit metaphysical, we could also think of this tree as all of the paths that are available in life. And imagine you're going along and you need to make a decision. At that point, the universe splits into 2 nearly identical copies. But depending on what decision we make, we could end up in 2 entirely different places. I thought this structure could make a neat poem, so I wrote this one. It's actually 16 poems in one. It's called Decision Tree. I'll turn it sideways so we can read it a little bit better. And so you start here. At the trunk of the tree is the question. Should I do it? Should I not? Then there's your decision. I shouldn't do it, so I thought, or I went and did it anyway. Next is your reaction to that decision, and then in the 4th stage is like how that affects you in the future. Let's take a look at a couple of these poems. There's, should I do it? Should I not? I went and did it anyways. But now I'm full of guilty thoughts. It wasn't worth it, I would say. Well, that's kind of depressing, right? Let's try a different one. Okay. Should I do it? Should I not? I shouldn't do it, so I thought, now the chance has slipped away. I guess I'm doomed to live this way. That one's kind of depressing too. Actually, a lot of these are kind of depressing. And I was a little surprised by that, but I think what's happening is I put some extra structure in here. I had this idea that one direction of the poem would be like how a good person would react. And the other direction would be like how a bad person would react. And so there's somebody here who actually feels good about themselves and is happy with who they are. It's this one right here. Should I do it? Should I not? I shouldn't do it, so I thought. I'll do what I know is right and keep my conscience clear and bright. But there's another person here who I think feels equally good about themselves. Can you see that one? Yeah, it's, should I do it? Should I not? I went and did it anyway. I just hope I don't get caught. They didn't catch me yesterday. So I'm not sure this says something about morality here, but I think it says something about happiness. That in life, as in mathematics, we're free to choose our own rules. We just need to make sure that our actions are consistent with our rules, or we're going to risk being unhappy. It's kind of a cool thing we can learn from math, huh? So all of these ideas here so far have just come from changing these numbers into shapes. And we could try turning them into all sorts of other shapes, and we could connect this to lots of ideas in mathematics. Here's a bunch of shapes that all have the same pattern in them. And these are cool and interesting ideas. They're all worth exploring, and they all can be great source for inspiration. Before we go too much further, let's give this pattern a name. Instead of using 1s, 2s, and 3s, we're going to replace the 1s with A's, the 2s with B's, the 3s with C's, the 4s with D's, etc. And we get kind of this interesting word pattern. We're going to call this the abacaba pattern. And if you want to try writing this down, it's pretty fun to do. The first step is you just write the letter A. Okay, then you double it and put the next letter of the alphabet in the middle. So we get ABBA. Double that and put the next letter in the middle, and we get abacaba. Double it again and put the next letter in the middle, and we come to abba, caba, dabba, It's kind of fun to say. Would you mind saying it with me? Can we say it together? Okay, ready? Abacaba, dabba. Okay, right on. Okay, next step then. Okay, double it and add the next letter in the middle. Now this has a little diphthong, a little double vowel in the middle, so it's got kind of an abacaba in the middle there. Okay, you ready for this one? Ready? Abacaba, dabba, dabba. All right, you guys are awesome. All right, let's go to the next one. Okay, let's say it together. Here we go. Abacaba, dabba, yabba, dabba, fabacaba, dabba, yabba, dabba. All right, yeah. Okay, that was the 6th step. We only have 20 more to go. Okay. Next one, you can do this one. You can practice this by yourself later, because this is G. If we double it, this is what it looks like to H. Double it again. And this gets ridiculously big fast. Okay, and if we take this all the way out to Z, it has over 67 million letters in it, and it would take us over 3 months nonstop to say that name. Imagine if you were to try to write it down. Well, I did that actually. I published this. It took a set of 4 volumes. Each was over 400 pages, and it was written in 4-point font. So I think this sets 2 world records right here. It sets the world's record for the longest published word, and it simultaneously sets the world record for the world's most boring book. I think you'll agree 1 page is probably enough, right? But I still really like this idea. Here's a magical sounding word that's impossibly long to say. I thought this would make a cool children's story. So I wrote this story called Maggie and the Abacaba Genies, about a young girl who finds a genie bottle, and she has to say these genie names to call up more and more powerful genies until she comes to the genie who lives at the letter Z. So these ideas now have come from changing that number pattern to letters. And also when I see letters, when I see A's, B's, and C's, I think of musical notes. What does abacaba sound like? Let's give it a try. We'd begin with A, and then we'd take the next letter, next note B, and repeat everything that came before A. Then we go to C, and repeat everything that came before. Now we go to D, and repeat. And it gets longer and longer till we use up the whole piano. I'm going to add a little bass line to this and turn it into a little song. Okay, thanks. That was fun. So that's a short version of a little longer song, and I've got this sheet music available for you if you want to try playing this at home. What I thought was neat about this song was that it sounds nice even though it's so structured. And I thought, well, if this is so structured, could we make a machine that plays this song? So I built this. This is the Abacaba music machine. You can hear it's playing the abacaba pattern by dropping balls onto a xylophone. And the balls go through this simple series of gates that send every other ball to the first note A, every fourth ball to a B, every eighth to a C, and so on. And what's kind of cool is the gates down the side, they're actually counting in binary from 0 to 127. Now, normally when we write numbers, we write them in decimal, which is base 10. So we have a ones place, a tens place, and a hundreds place. And when we write like 375, we really mean 3 hundreds, 7 tens, and 5 ones. And with binary, instead of powers of 10, we use powers of 2. So we have a ones place, a twos place, a fours place, an eights place, and so on. So if we write 1 0 1 1, that means 1 8, 0 fours, 1 2, and 1 1, which is how we would write the number 13. So with just zeros and ones, we can write all of the numbers from, here's the start of the list right here, from 0 to 16. And binary is full of abacaba patterns. For example, if we just look at how many zeros there are at the end of each number, there's an abacaba pattern. There's lots of other places too. How about if we color in the digits? I'll leave the zeros white and we'll color in the ones black. We get this kind of weird looking shape. If you turn your head sideways, you might be able to see there's an abacaba tree right in there in the binary numbers. I thought this looked a little lopsided, so I made 2 copies and stuck it together so it would be a little more symmetrical, and got some interesting little shapes. Do you see what I see in there? Yeah, there's fish. It's full of fish. So this became a picture. Here's two solid fish and two ghost fish swimming in the seaweed made out of the numbers from 0 to 15. And I called this one Pisces after the zodiac sign with two fish. I wrote the name a little bit funny because the picture has a nice upside-down symmetry to it, so I wanted the name to also read the same if it was going upside down. If we go back to this idea with lengths, if we write this binary numbers using these blocks in doubling lengths, we can begin to count 1, 2, 3, 4, 5, 6, 7, and we begin to see some neat shapes coming up. We get a bunch of squares. It looks like steps. It maybe looks a little bit three-dimensional. And if we think of the smallest squares as A's, and the next bigger ones as B's, and the next bigger ones as C's, then we get this abacaba pattern as we walk up the staircase with the steps that we step on. So I extended that pattern out to 255, and I took several copies of it and put them together and got something that really is looking 3D. This became a piece of like op art, and it also started me thinking about three-dimensional. What would this look like in 3D? So I tried some paper clipping, and then here's a pop-up card that I made. I have some instructions available for this too. If you want to make one at home, it makes a great art project. And I really wanted to walk up these steps. I built models out of wood, and I began making computer models. Here's one that is completely symmetric in 3D, and I flooded this with water, and I got like this awesome looking planet. I really wanted to be on this planet, so I began designing landscapes, and I began to live in this world in my head. And this became the basis for a fantasy novel that I've just written. It's called Abacabax, and it takes place on this planet where the middle block is this letter X in the pattern. And I filled this world with people and monsters and magic and mathematics and lots of connections to the abacaba pattern. And to me, there is nothing closer to real magic than mathematics. So all of these ideas that we've seen have come from this one abacaba pattern, and there's so much more. I've made a lot of resources available on abacaba.org if you want to see some more art, or listen to some music, or download some activities or games. So just think, if one pattern can inspire art and music and poetry and sculpture and landscape and architecture and literature, what might other patterns do? So I hope you go out there, play with some ideas and some patterns and put them together in different ways and see what you can find. You might be surprised at all the beautiful things that you could create. Thank you.